So hello everyone, how are you all? I hope you all are doing great. Welcome back to the SISYA class channel. Today we are here for something very interesting. What we are here for? Studying about a square and a cube. That is basically a grade 8 chapter number 1, a square and a cube. So let me first introduce about myself. My name is Dhananjay. I've done my masters in mathematics from NIT Durgapur and taught over thousands of students for the JEE. Now, if you see in square and a cube, so sometimes you see that some numbers starts repeating again and again in mathematics, like 4, 25, 64, 125, 625. Why it happens? Because these numbers belongs to a very specific families of mathematics that is called a square and a cube. So mainly we are exploring these numbers in today's class. Clear? So before starting the class, let me tell you something about the SISYA class application. So if you want more such interactive sessions, please explore the SISYA class application where you will see the booster courses, Maths Champs courses, SISYA Toppers programs and many more. So what you have to do, just simply go to sisyaclass.com/LTC and enter your grades. It is from grade 1 to grade 10. Just tap on that according to your grades. The pop-up will appear. Simply you have to fill your mobile number and your state name. Then you can try 3 classes at just ₹99 only. Interesting? Right. Okay. Now let's quickly go to what we will cover today. So this chapter is basically of 2 parts. Part 1 is squares and part 2 is cubes. So इस वीडियो में हम स्क्वायर्स को देखेंगे, पार्ट 2 मेनली हमारा क्यूब्स के ऊपर रहेगा. ठीक है? So in the first video we will deal with the squares only. So what are the topics that we will cover? In squares, firstly we'll cover about the perfect squares and their properties. Then we will see about the interesting number patterns. Don't worry if you don't know the index, I'll keep it very simple. Finding squares fast with the help of column method. Then Pythagorean triplets. Square roots, how you can find square root fast. There are 3 methods. I'll explore to that. Then at the end we will see finding the square roots of decimals and estimation. Okay. So now let's start with a square and a cube. First question, what is a square and what is a cube? So a square means simply when you multiply the same number 2 times. What I said, if you will multiply same number 2 times, you will get a square number. Let us suppose we have a number 4 and what I did, I multiplied it 2 times. So 4 square, it is written as 4 raised to power 2. 4 raised to the power 2, where 4 is a base and 2 is a power. Okay, the meaning of this is 4 is multiplied 2 times. Okay, so 4 square is 4 into 4, that is basically 16. Clear? So if I have to find the 5 square, so what I'll do, I'll multiply 5 2 times. So 5 into 5, that is 25. If I have to find 6 square, so I'll again multiply 6 into 6 2 times. Okay, so 6 into 6, that is 36. Clear? This is what square is. Now what is the meaning of cube? In the same way you multiplied in square 2 times the same number, in cube you have to multiply 3 times. So if I have to find the cube of a number which is written as 4 raised to the power 3, 4 is a base, power is 3, or you can say exponents as well. So 4 into 4 into 4, just multiply same number 3 times. So 4 into 4, 64, and into 4 is 4 into 4, 16, 16 into 4 is 64. Clear? Now let's find the cube of 5. Cube of 5. Cube of 5 is multiply 5 3 times. 5 into 5 into 5, which is 125. Clear? So in square you have to multiply same number 2 times. In cube you have to multiply same number 3 times. I hope this is clear to you. From now on we will be mainly dealing with a square in this video, not a cube. This I'll cover in part 2 in later classes. Clear? So the square is clear to you? Okay, moving ahead with the same energy. Now let's come to what is a perfect square. So in previous slides we have found that the square of 4 is 16. Okay, the square of 5 is 25. The square of 6 is 36. So what are these numbers? 16, 25, 36. These are perfect squares. Why? Because these are formed with the multiple of a number 2 times. Why 16? If I have to write 16, if any number can be written as a multiple of the same number 2 times, it is called a perfect square. Now here the number should be natural numbers. So keep in mind. So 16 is a perfect square. In the same way 25, can I have a number, if I'll multiply with the same number, can I get 25? Obviously there is a 5. If I'll multiply with 5, I'll get 25. So 25 is a perfect square. Means if any number, let's say the number is n. If I'll multiply n into n, where n is a natural number, n into n, where n is a natural number, then here capital N will be a perfect square. Perfect square. Clear? I hope it is clear to you. So this is what written here. A natural number is a perfect square if it can be written as a n cross n for some natural numbers. For n cross n for some natural number. In other words, it is the product of a number multiplied by itself. Clear? So what is the geometrical meaning of it? Geometrical meaning is, suppose any perfect squares we have. Let us suppose 16. So if I can arrange it in a square structure, like here if you observe, there is a dots, 4 rows we have, 1, 2, 3, 4, right? 4 columns we have, 1, 2, 3 and 4. So we have 4 rows and 4 columns. 4 rows and 4 columns. So this is a structure of a square, right? Both sides equal. So this is a square. So square number can always arranged in the structure of a square. This is what the geometrical meaning of a square number. This is clear to you? I hope this is. Any doubt? If you have any doubt, you can ask me in the comment box. Clear? Now let's come to the next topic, that is a perfect squares from 1 to 20. This one you have to remember. Why? Why? This is pretty simple, right? If you will find the square of 1, what it will be? Just multiply 1 2 times, it is a 1. If you will multiply 2 2 times, you will get 4. So the square of 2 is 4. For 3 it is 9. For 4 it is 16. For 5 it is 25. In the same way, for 15, if you will multiply with 15 again, you will get 225. For 19, if you will multiply with 19, you will get 361. For 20, if you will multiply with 20, you will get 400. So just remember, this is your homework and you have to remember this table. At least remember till 20, the squares till 20, so that the questions will be easy for you. Why? Because this we will use again and again in the upcoming questions. Clear? Now, if you observe the white ones, all these numbers are perfect squares, right? 25, obviously these are square numbers, so this can be written as a multiple of 5 into 5. Clear? 100, I can write this as 10 into 10. 81, I can write this as 9 into 9. So this was the definition of perfect squares, right? Now let's come to a properties of square numbers. Now these square numbers follow some patterns and properties. This you have to remember. So a number, property number 1 is a number that ending with 2, 3, 7 and 8. A number which is ending with these numbers can never be a perfect square. And a perfect square always end with 0, 1, 4, 5, 6 or 9. Sir, I didn't get the property number 1. Okay, let me explain you. If I'll write any number here, 5, 4, 2, 3, and I'll ask you, is this a perfect square? What should be your answer? Everybody please write in the chat box. What do you think? What should be your answer? Good evening. What should be your answer? 5, 4, 2, 3. Is this a perfect square? The answer is big no. Why? This is not a perfect square because it is ending with the digit 3. If you see the last digit, it is 3, right? So this is not a perfect square. Perfect square always end in 0, 1, 4, 5, 6 or 9. This is a necessary condition to be a perfect square. Okay, so 5, 4, 2, 3 is not a perfect square. What about 8, 4, 3, 7? Is this a perfect square? 8, 4, 3, 7? No. Again, this is not a perfect square because the last digit is 7. So just keep remember 2, 3, 7 or 8. If any number is ending with these digits, it will never be a perfect square. Clear? It will never be a perfect square. But if a number ends with 0, 1, 4, 5, 6 or 9, will it be a perfect square? Think. The answer is may or may not be. So let us suppose if a number is 5, 5, 3, 5, 3, 3 and 6. Is this a perfect square? Tell me. The last digit is 6. So I cannot say directly that it is a perfect square or not. So this may or may not be, you have to check by yourself. May or may not be. Clear? So this is the property number 1. Now let's come to property number 2, and it says that if a number ends in an odd number of zeros, it cannot be a perfect square directly. It can never be a perfect square. Odd number of zeros means, sir, odd number of zeros means odd number, you understand? The number which is not divisible by 2. So odd number of zeros means if a number is 5 and we have odd number of zeros, 5,000. Is it a perfect square? No, this cannot be a perfect square because we have odd number of zeros at the end. So this cannot be. Is 8,000 a perfect square? No, 8,000 is not a perfect square because we have 3 number of zeros. So it is not a perfect square. What about 9 with 5 zeros? Is this a perfect square? Again, the answer is no. So you can neglect the options, right? So these are very important properties. You need to keep remember it. First one, a number ending with 2, 3, 7 or 8 can never be a perfect square. Second one, a number ending in an odd number of zeros can never be a perfect square. Shall I move to the property number 2 now? Property number 3. Yes, property number 3 says that a square of an even number is always even and a square of an odd number is always odd. What is the meaning? So let us suppose we have even number. Even number is a number which is divisible by 2, right? So let us suppose 8 square. 8 is an even number. Yes sir, 8 is an even number. So what is 8 square? 8 square is 64. Is 64 an even number? Yes or no? Yes sir, 64 is an even number. So earlier we had 8 which is even number. Its square is an even number. What about 6 square? 6 square is 36. So 6 is an even number, 36 is an even number. So square of every even number is an even number. What about odd number, sir? Odd number, let's see. 5 square, sir. 5 square. 5 square is 25. 5 is an odd number and its square is also an odd number. What about 13, sir? 13 square. So 13 square is 169. So 13 is an odd number and its square is also an odd number. So these are three properties that we have. The third one is the square of an even number is always even and the square of an odd number is always odd. So these three properties are clear to you. Now you can counter question based on these properties. Now let's quickly review. Can 4, 3, 2, 7 be a perfect square? 4, 3, 2 and 7. See at the end, property number 1. These numbers ending with digit 7. Is this a perfect square? No, sir. This is not a perfect square because at the end we are getting 7. That's why it is not. Clear? What about 5499? 5499, sir. What about this number? See at the end, the last digit is 9. Is it a perfect square? Tell me. At the last it is 9. So can I say directly that it is a perfect square? No. This may or may not be. You have to check. Okay? Clear? 5499 may or may not be a perfect square, but this is not a perfect square. Okay? So it is a necessary condition, but not a sufficient condition. Clear? What about this 9 with 4 number of zeros? Is this a perfect square? Tell me, think. Think. Is this a perfect square? So we have 4 number of zeros. Property number 2 says that if we had odd number of zeros, then it cannot be a perfect square. But here we had even number of zeros, right? We have 4 zeros. So it can be a perfect square, but is it always be a perfect square? No, we have to check. We have to check it. So what is the 99 with 4 zeros? Will this form a perfect square? We'll see that it is a perfect square or not. Obviously, this is a perfect square. Okay? Later on, we will see that how it is a perfect square. So if you will multiply the same number and if you will get this, then it will be a perfect square. 90,000. If you multiply the two numbers and you will get the 90,000, then it is a perfect square. Clear? What is the number? Can you tell me? Okay, 300, if you multiply with 300, you will get 90,000. I hope this is clear to you. Now let's see the patterns that a square number follows. So there are some patterns. First one is the sum of consecutive odd numbers, right? Sum of consecutive odd numbers. What is the meaning of consecutive odd numbers? So 1, 3, they are odd numbers and they are consecutive odd numbers. 3, 5, 5, 7, like this. They are consecutive odd numbers. So the sum of first n odd natural number is n square. What is the meaning of this? First n odd natural number. See the pattern. If you will add 1 plus 3, 1 plus 3 is 4, which is 2 square. Clear? 1 plus 3 plus 5. Add the next odd number, consecutive. 1 plus 3 plus 5, that is 9, which is 3 square. Okay. Next odd number, if you will add 1 plus 3 plus 5 plus 7, what you are getting? 16, which is 4 square. So are you observing any pattern? When I'll add two consecutive odd numbers, it is 2 square. When I'll add 3 consecutive odd numbers, it is 3 square. And if I'll add 4 consecutive odd numbers, it is 4 square. Clear? So if I'll add n consecutive odd numbers, it will be n square. This pattern is clear to you? Okay, this also gives a way to find square roots by repeated subtraction. What it means? We'll see this in finding the square roots. There is a method called repeated subtraction that we'll see in the later on. Clear? This was pattern number 1. Now let's come to a pattern number 2. Okay, if you have any doubt, you can ask me in the comment box. Okay, let's come to pattern number 2, that is numbers between square numbers. Okay, numbers between a square numbers. What it means? Let us suppose we have two numbers 7 and 8. 7 and 8. Just try to find its squares. Everyone knows how to find the square. Just multiply this number 2 times. So it will be 49. 8 square is 64. Clear? So how many non-perfect squares number exist between these two numbers, 49 and 64? Understood the question? Between two squares of two consecutive numbers, how many non-perfect squares numbers exist? If such kind of questions will appear, see, this kind of tricks is very helpful. Let us suppose this is n that I have chosen. N means n I have chosen as 7. So this can be written as n square. Yes or no? What is the next consecutive number of n? That is n plus 1. Means if I'll choose n as 7, n plus 1 is 8. So n plus 1 square is 8 square. So how many numbers which is a non-perfect square appear between these two? Which is basically 2n non-perfect square numbers. Clear to you? So if I'll find the square of n and n plus 1 square, in between we have, this is 2n number of non-perfect squares number. This is the concept and this is a pattern that I have shown here. Visualize it. 49, 64. What are the numbers between them? 50, 51, 52, 53, 54, like that till 63. So how many numbers are in between? 1, 2, 3, 4, 5 total. 2 into 7, 14 numbers. Okay. 14 numbers are there between 49 and 64, which is not a perfect square. Okay. Any doubt? You can ask me. So this was the two pattern that you need to remember. The first one was sum of consecutive odd numbers, which is n square, and the second one is the numbers between two consecutive numbers n and n plus 1 are 2n numbers. Okay. Now let's see that how we can find the squares of any numbers quickly. This method is called the splitting method. Splitting method, for splitting method you have to remember one identity, that is a plus b whole square. I know that everyone remembered this from the junior classes only. A plus b whole square equals to a square plus 2ab plus b square. Now there is one more identity, that is a minus b whole square. Okay. A minus b whole square, which is a square plus b square minus 2ab. This is also a plus b whole square. It can be derived from this formula only. So just remember this formula, a plus b whole square, and you are ready to go to tackle the questions of this concept. Suppose if you have to find the square of 68. So we have 68. So which is the closest number of 68 whose squares are easy to find? 70, right? So can you write 68 as 70 minus 2? Same thing. You can write 60 as at 70 minus 2. Now what you have to do? You have to find its square. So square both sides. 68 square equals to 70 minus 2 square. So I'll apply this formula here, a square plus b square minus 2ab. So this is 70 square plus 2 square minus 2 into 70 into 2. Clear? So this will be 4900. This is 4 and this is 280. Clear? So if you will solve this, you will get 4624. So the square of 68 is 4624. Normally what you do is, if you have to find the square of 68, you will multiply 68 with 68 and you will get 4624. Now this is little bit tedious task to do. So what you can do, you can split this number in two numbers in such a way that the square of one number is easy to find. Clear? And now you can solve it mathematically about the using the identity a minus b whole square. Clear? So I hope this concept is clear to you, that how you can find the squares by splitting method. Fine. Now let's come to a next concept, that is a Pythagorean triplets. What is this? This is very important and very interesting at the same time. See how. All of you did study about the Pythagoras theorem in your junior classes? Yes or no? Pythagoras theorem? Yes. What it says, sir? So suppose if we have a right angle triangle, this is a hypotenuse, this is perpendicular, and this is base, right? So the Pythagoras theorem says that PT for Pythagoras theorem, hypotenuse square equals to perpendicular square plus base square, right? Hypotenuse square equals to perpendicular square plus base square. So what is the use of this theorem here? Yes, you can find these triplets. How? With the help of square numbers. This is the application, right? Very beautiful. So if you want to find the triplets, one concept that you have to use is 2m. For the first number you have to use 2m, then m square minus 1, m square plus 1. Okay, 2m, m square minus 1, m square plus 1. Now what is m, sir, here? M can be any natural numbers. You can take m as 2, 3, 4, 5, 6, 1, 2, any counting numbers you can take. So let us suppose I have chosen m as 6. So if I'll take m as 6, what is the triplets that we are getting? 6 into 2, 12. 6 square minus 1. 6 square minus 1 is 30. 6 minus 1, that is 35. 6 square plus 1, 36 plus 1, that is 37. So 12, 35 and 37, this is the Pythagorean triplets. Why it is a Pythagorean triplet, sir? Because it will satisfy this criteria. A square plus b square equals to c square, which is basically hypotenuse square equals to perpendicular square plus base square. Clear? Let's see how it is satisfying. So if we'll make a right angle triangle and perpendicular as 12, right? And base as 35. So if you'll observe, 12 square plus 35 square equals to 37 square. This you can verify. Please verify by yourself. I have done here. Please verify this. Find the square of 12, square of 35. You will see that if you will add these two numbers, you will get the square of 37. Clear? Here I have found The square of 12 is 144. The square of 35 is 1225. And the square of 37 is 1369. So left hand side equals to right hand side, means Pythagoras theorem are satisfied here. Clear? So Pythagorean triplets are clear to you? I hope so. Now let's move on to the next concept. If you have any doubts, you can ask me. Once again, I am asking. Any doubt? No? Now we are done with the square numbers. Now we are going to start a new topic, that is square roots. Now this is not a new topic, it's just an extension of square numbers, just a reverse process of square numbers. What is the meaning of reverse process? So earlier what you were doing, you were finding the squares of any numbers, right? Let us suppose you were finding the squares of 5. So the square of 5 is 25. Yes, sir. Now what you will do? You will find the square root of this number. So the square root of this number is denoted by this sign. This radical sign, the meaning of this is square root. Here we have 2. Clear? The meaning of 2 is, on numbers, the power is 1 by 2. What is the meaning, sir? The power is 1 by 2. Writing square root of 25 or 25 raised to the power 1 by 2. Same thing. So what is the square root of 25? That is 5. If the square of 5 is 25, the square root of 25 will be 5. That is why I told you that the square roots are reverse process of squaring. Okay? Square roots are reverse process or inverse process of squaring. So if we have n square equals to m, so what is root m? This is basically root n. Here also we have done, if the square of 5 is 25, what is the square root of 25? It is 5. I hope it is clear to you. Next is, every perfect square has exactly one positive square root. Every perfect square everyone knows, perfect square is 64 a perfect square. Think, 64 a perfect square. Yes sir, 64 is a perfect square because we can multiply 8 2 times and we can get 64. So if I have to find the square root of 64, we will get 8. So every perfect square has exactly one positive square root, exactly one. So this is clear to you. Suppose I have to find the square root of 121. So 121 is a perfect square, yes or no? Think once again. Yes sir, 121 is a perfect square because if I'll multiply 11 2 times, I'll get 121. So if I have to find the square root of 121, I'll get 11. So square root goes hand in hand. So if I have to find squares of 11, it is 121. Find the square root of 121, we'll get 11. So this is clear to you. Mainly what we have to do in square roots, its meaning and their symbols. Its symbol is this radical sign or any number to the power 1 by 2. Okay, this is how we denote the square roots. Now there are some methods to find the square roots of a number. The first one is the repeated subtraction method. Repeated subtraction method, what is the meaning of it, sir? I'll explain through an example. Suppose if you have to find the square root of 64, right? So one way of thinking is that, sir, is there any number that if you multiply 2 times, we'll get 64? That is the meaning of square root, right? Obviously there is a number, but thinking about number is little bit difficult. If this is a big number, how will you do it? So what I'll do, I'll use one method. First one is repeated subtraction method. I'll also tell its demerits also, that when we will use this and when we will not. Okay, so 1, 3, 5, 7, subtract these odd natural numbers from the number. So first step, what you have to do, you have to subtract 1 from 64. that is 63. Okay, sir. What is the next step? Next step, you have to subtract 3, the next odd natural numbers. That is what we have done in square numbers, right? 64 minus 3. So it is, 63 minus 3. This step you have to find 63 minus 3, right? In first step, 64 minus 1 is 63. In the next step, you have to do 63 minus 3, which is 60. What will be the next step, sir? The next step will be just subtract the next odd natural number. So 60 minus 5 is 55. 55 minus 7, sir. 55 minus 7, it's 48. What next, sir? So 48 minus 9. Do it until we get 0. 48 minus 9. What is the number? 55 minus 7, 48. 48 minus 9, what is the number? 39, right? 39. This number we will get. 39 minus 11. Next step. So 39 minus 11 is 28. Next step, 28 minus 13. This looks lengthy, but it is not. 28, that is 15. 15 you are getting. The next step you will get the answer. 15 minus 15 equals to 0. So until and unless you will get to 0, you will not stop. So just count the number of steps or just count the number of odd natural numbers that you have subtracted from the given number. So this one is the first step, second, third, 4, 5, 6, 7 and 8. So what will be the square root of 64? So the square root of 64 will be 8. Clear? How to find the square root by repeated subtraction method? You have to subtract the odd natural numbers and just count the number of subtraction, that how many numbers we have subtracted. So here we have subtracted 8 odd natural number. So the square root of the number is 8. Clear? So this is one method to find the square root of a number. Let's come to another method, that is prime factorization method, and this is a very important method and very famous as well. Prime factorization method, this is very important for your examination point of view. So if you have to find the square root of 576. Now previous method where it fails, this method, why we needed the prime factorization method? So if you will observe that if we have a big number, let's say 125, let's say 625, if you have to find its square root, so should I subtract 1, 3, 5, 7, 9, 11, 13, 15, 17, 19 like that again and again? No, this will be little lengthier process for big numbers, right? This will be a lengthier process for big number. So we have another method called prime factorization method. So let us suppose if you have to find the square root of 576, this number, what will be its square root? So how to find it? What is the meaning of prime factorization? So meaning of prime factorization is you have to write this number in such a way that it comes to a multiples of any prime numbers or powers of a prime numbers. If it can be written as a multiples of powers of prime numbers, that is called a prime factorization. So how shall we do it? So we have 576, right? So try to break it. Which is the smallest prime number? Everyone knows 2. So if I'll cut it with 2, we have 2 2s are 4, 2 8s are 16, 2 8s are 16. Okay, please check. 2 2s are 4, 2 8s are 16, 2 8s are 16. Once again with 2, 2 ones are 2, 2 fours are 8, 2 fours are 8. 2, 2 sevens are 14, 2 twos are 4. 2, 36, again with 2, 18, right? 9, 3 threes are 9, and 3 ones are 3. Clear? 3 threes are 9 and 3 ones are 3. This is visible to you, right? So, can I write 576? 576 as how many 2 we have? We have 1, 2, 3, 4, 5, 6 2s. We have 6 2s. Can we write it in pairs? So 2 into 2. How many pairs we have? If you have 6 2, then you can make 3 pairs of 2, right? So 2 into 2, 2 into 2, 2 into 2. How many 3 we have? So we have 2 3s, right? This is 1 and this one is 1. So we have 2 3s. So how many pairs we have? We have 1 pairs of 3. So I'll write 3 into 3. So if you have to find the square root of 576, what I'll do? See the process. If I have to find its square roots, I'll take one number from each pairs. So from the first pair, I'll take 2, from second, one number, from the third pair, I'll take one number, from the fourth pair, I'll take one number. So this is 2 into 2 into 2. That is 8, 8 into 3 is 24. So the square root of 576 is 24. This is how you have to tackle question. Now this one will be homework for you. You can simply find square root of 324 and it will come out to be 18. Right? This is the method that you have to use, but once again I am telling you, it is better than the previous method, but it is also not sufficient method. Why? Because if you will get a bigger number, then will you do it? Will you do this prime factorization? This will again be a lengthier process for a very big number. So there is another method called long division method. What you have to do in this method, I'll explain it step by step through an example. Suppose if you have to find the square root of 1369, okay, the square root of 1369. So what you have to do, you have to write this number, 1369. Okay, now make it pairs. Make a pair of digits from the right side. From the right side you have to make pairs. One pair is this, another pair is this, and you have to find its square roots. So what I'll do in the next step, I'll make a line here and here also I'll make a line. Clear? So this is what you have to do in long division method. You have to find a number which is whose square is less than 13. Okay? You have to find a number whose square is less than or equals to 13. This is the first step that you have to do. So let's find it. What is the square of 4? Square of 4 is 16, which is greater than 13. So I cannot choose this. What is the square of 3? Square of 3, 9. Right? So square of 3 is 9. So I'll write 3 here. Yes or no? I write 3 here and 3 at the top. 3 at the left and 3 at the top. This is the first step that we have to do. What is the next step, sir? So just simply multiply these 3 and 3. So if you multiply 3 and 3, you will get 9. Right? Just subtract this 9. So if you subtract 9 from 13, what you will get? 4. 4, and the pairs just write it down as it is 4, 6, 9. Here what you have to write? What do you think? What I should write here? 3. So the same number just simply add in the bottom. 3 plus 3, that is 6. Okay. Now what will be the next step? So the next step will be, you have to think about a number here. There will be one digit number here. You have to think about it in such a way that if you will multiply with the same number, you will get 469. Clear? The next step is clear to you. You have to think about a number such that if you multiply with the same number, you will get 469. So what is the number here? Think. 6. If I'll multiply with 1, no, 61 will only get. If you multiply with 2, no, at the end we are getting 4. No, here it is 9. Let us suppose if I'll multiply with 7. So 67 into 7. So 7, 7, 49, 9. This is 46. So if you multiply 67 into 7, you will get 469. So you have to write 7 here. Okay. This is a hit and trial method. So you have to think about a number. This is pretty simple. You will get it. So if you multiply 7 here, you have to write 7 also at the top. So 469, 469, 67 into 7 is 469, which is basically 0. So if you add 7 at the bottom, you will get 7 plus 7, that is 4, 6 plus 1, 6 plus 1, 6 plus 1, 7, 74. So, where is the square root of this number? So, the topmost number is the square root that you are getting. So, the square root of 1369 is 37. I hope this steps is clear to you. This is looking lengthy, but if you will practice it again and again, this will be easier for you. So, the square root of 1369 is 37. Clear? So this was the third method. It is long division method. Now there is also that sometimes there will be numbers, how to find the square root of decimal numbers, right? Suppose if you have to find the square root of 13.64, right? So now what you will do? 13.64. Here also long division method are useful. See how I will find it. 13.64. So write it down, 13.64. Same thing, long division method. You can use the estimation value also here, but we'll see later on. Firstly, see the decimal numbers, how you can find using the long division method. It's square roots how we can find. Okay. So just pair it. But there is a rule in pairing here. Pair the digits before the decimal point from the right to left. Before the decimal point, you have to pair from right to left. But here we had only one pair, so this is 17. Pair the digit after the decimal point from left to right. From left to right. Here we have one pair, so it is 64. So this is the first step that you have to do. You have to make a pair. Now the next is you have to apply the long division method normally. So which number can you think of a number whose square is less than 17? Less than or equal to 17? Obviously, sir, 4 square. So this was the first step in our long division method, right? So 4 square is 16, which is less than 17. If I'll find 5 square, it is greater than 17. So that is of no use. So 4 square, I'll write 4 here, 4 at the top. So 4 into 4, 16. That is 1, 6, 4. Just write the pairs here. I'll add 4 numbers. 4 plus 4, 8. This is what you have to do. Now here we have a decimal point. So I'll put decimal here. Clear? Okay, I'll put decimal here. Now next step, what we have to do? We have to again think about a number that multiplied with the same number and give the number 164 or less than 164. Can you think about a number? Just try to think. If I multiply with 1, it is 81. If I multiply with 2, so what's the number you are getting? Just fill here 2. So 2 2s are 4 and 8 2s are 16. So 164 you are getting, right? 164. So write here 2 and in the top also it will be 2. So 164, if you will multiply 82 with 2, you will get 164 and here 0, just add 2 at the bottom, you will get 4 and 84. Clear? So what will be the square root of root 17.64? So root 17.64, its square root will be 4.2. Clear? So this is how you have to find the square root of any decimal numbers. Clear? Pretty simple. So these are the methods to find the square roots. Now let's come to the last method, which is the estimation method of square roots. Estimation means approximating. We are approximating the square roots. So suppose if you want to find the square root of 55, can we approximate these square roots? Obviously, sir. First of all, this is a non-perfect square. 55 is a non-perfect square, obviously. Otherwise, you would have answered easily. So 55, if you have to find its square roots, think about two numbers which is closer to it and it is a perfect square. Which is closer to it and it is a perfect square. So basically, what is the square of 7? So square of 7 is 49, which is less than 55. What is the square of 8? Square of 8 is 64, greater than 55. So this number 55 is between 49 and 64. Clear? So this is a 55 which is between 49 and 64. So 55 is closer to which number? 49 or 64? One thing I know that the square root will always lie between 7 and 8. Square root will be 7 and 8. 7.3, 7.4, 7.5, 7.6. That can be any number till now. But this number, if you will observe, it is closer to 49 rather than 64, right? This is closer to 49 rather than 64. So the square root will be closer to 7 rather than 8. Clear? Means square root will be always less than 7.5. So its square root will be 7.4 approximate. If you will approximate till one digit number after the decimal, it is 7.4. Clear? So this is how you have to estimate the square roots when the number is not a perfect square. So the exact approximation is 7.416. Clear? Till one decimal you can approximate its values as 7.4 and you can write it down. This is correct. So everything is clear to you. Okay. So these methods we have studied. Let's quickly practice what we have studied till now. The first question is 2025 a perfect square? If yes, find its square roots. 2025 a perfect square? If yes, find its square roots. How will you do it? 2025. Please think this. 2025. I am giving you this as homework. Is it a perfect square? Tell me yes or no in the chat box. Is it a perfect square? Okay, you have to do this by a long division method. By a long division method, just find its square root. What is the square root of 2025? This will be your homework. You have to find the square root of 2025. Is if that is a natural number, then it is a perfect square. Clear? This is the example number. Let's come to example number 2. You have to find the square of 89 using the split column method. Okay? Using the split column method, 89 square. I am giving you concept. Please solve it, everybody. 89 square. Split method. Split method means you have to split these numbers into two numbers such that one number squares you already know. So 89, which is closer to 90, right? So can I write this 89 as 90 minus 1 square? Now use this identity, a minus b whole square. It is a square plus b square minus 2ab. Okay, so if I apply here, 90 minus 1 whole square is 90 square plus 1 square minus 2 into 1 into 90. Just solve it simply. So 90 square is 8100. What is the 1 square? 1 square is 1. What is 2 into 90? 2 into 90 is 180. So 8100 plus 1 minus 180 means basically 8100 minus 179. Let me check. 90 square plus 1 square minus 2 into 90. Okay, so 8100 plus 1 minus 2 into 90, that is 180. So 8100 minus 179. Just you have to simply subtract it. You will get 10 minus 9, 1. Just simply subtract 179 from 8100. You will get 10 minus 9, 1. 9 minus 7, 2. 9. 10 minus 1, 9. And 7. 7, 9, 2, 1. Right? Please check it. 7, 9, 2, 1. Is it correct? 7, 9, 2, 1. Is it correct or not? Okay, fine. So now let's move on to the next question, that is question number 3. You have to find the square root of 2704 using the prime factorization. Prime factorization 2704. Can you do it with prime factorization? Obviously, sir. With 2, is it divisible by 2? 2 1s are 2, 2 3s are 6, 2 5s are 10, 2 2s are 4. 2 1s are 2, 2 3s are 6, 2 5s are 10 and 2 2s are 4. So once again it is divisible by 2, 2 6 are 12, 2 7s are 14, 2 6 are 12. So 6 7 6. Once again with 2, 2 3s are 6, 2 3s are 6, 2 8s are 16. With 2, 2 1s are 2, 2 6 are 12, 2 9s are 18. 13, you can write here 13. Please verify it. 13 into 13 is 1. So can I write 2704 in the multiples of prime numbers? Obviously 2. Can we write in pairs? 2 into 2, 2 into 2 and 13 into 13. So 2, if you have to find its square root, what you have to take? You have to take one numbers from the pairs. So here it is 2, one number from this pair it is 2, one number from this pair 13, that is 52. So the square root of 2704 is 52. Means if you will multiply 52 2 times, square of 52 will be 2704. Verify once. 52 if you will multiply with 52, you will get 2 2s are 4, 5 2s are 10, 5 2s are 10. Yes, 4072. 2704 means 52 square is 2704. So if you have to find the square root of 2704, you will get 52. So this was the question number 3. Now let's move on to the question number 4. That is, you have to write the Pythagorean triplet for m equals to 9. For m equals to 9. For m equals to 9, what was the formula for triplet? We have 2m, m square minus 1, m square plus 1. So if you will put m as 9, it is 18. M as 9, it is 18. If you will put m as 9 here, m square minus 1, 81 minus 1, that is 80. 80 plus 1, 81 plus 1, it is 82. So it will satisfy the Pythagoras theorem, and this will be the Pythagorean triplet. So you just need to remember 2m, m square minus 1, m square plus 1. I hope this is clear to you. Question number 5. This is how you can do it. How many square numbers lie between 15 square and 16 square? 15 square, this is n, right? N square. 16 square, this is n plus 1, right? So direct formula we have, between n and n plus 1, how many total non-square numbers? 2n. So it is 2 into 15, that is 30. 30. So we have 30 non-square numbers between 15 square and 16 square. And this is the last question that I am giving you as homework. You have to do using the estimated method. You have to find the square root of 5.25 correct to 1 decimal places using the method of estimation. Clear? Estimation method, the long division method you have to use. Okay, so that's it for today. So if you want more such interactive classes, please visit on to SISYA classes and explore the courses of booster courses. We have maths year-long courses and SISYA topper program. So if you want to take enrollment, so just tap on your grades, visit the sisyaclass.com/LTC first website, and then tap onto your grades. The pop-up will appear and you have to fill in the mobile number and your state name. Okay, so if you like this session, please hit the like button and share it and subscribe the SISYA YouTube channel. Thank you so much everybody. Have a good day.